Assalamu alaikum students, welcome to our fourth lecture. Today we will discuss about prefixes, that what are prefixes, and then we will look some of the examples of the prefixes. Also today we will do some problems related to the prefixes such as problem 1.1, 1.2 and 1.3. So what are prefixes? Some of the physical quantities, as we have discussed last time, that we have physical quantities which we use to measure something, and some of the quantities they are either very large or very small, but SI units have the advantage that their multiples and submultiples can be expressed in terms of prefixes. So what are prefixes? Prefixes are words or letters that are added before the SI units such as kilo, mega, giga and milli. Like these are some of the examples of the prefixes. So prefixes are the simplified description of physical quantities, such quantities that are either very big or they are very small. So you can see a table here in this slide that we have different multiples of the 10, and they have specific name right there, and they have a specific symbol right there. Like you can see here, the kilo is 10 to the power of 3 and it is represented as small letter k, whereas we have mega, which is 10 raised to power 6 and it is denoted by capital M. Then we have giga, which is 10 to the power of 9 and it is represented as capital letter G. And you can also see on the other side of the table like deci, which is 10 raised to power minus 1 and it is denoted by a symbol small d. Then we have centi, which is 10 raised to power minus 2 and it is denoted by small letter c. Then we have milli, which is 10 raised to power minus 3 and it is denoted by small letter m. Similarly, we have micro, which is 10 raised to power minus 6 and it is denoted by mu, which is the symbol of micro. Then we have nano, which is 10 raised to power minus 9 and it is denoted by small letter n. So you need to remember these important prefixes and their multipliers as well as their symbols. You can see an example here, like if we divide 10,000 grams by 1000 to express it into the kilogram, and as you can see here, the kilo is basically 10 to the power 3, or this means 10 cube. Like if we multiply 10 3 times, like 10 multiplied by 10 multiplied by 10, it would be equal to 1000. So 10,000 gram, we can convert this into kilogram by simply multiplying it by 1000. So when we multiply it, divide by 1000, so we will get 10 kilogram. So 10,000 grams, these three zeros can be simplified with 10 raised to power of 3. So we can say 10 kilograms. So this letter K is basically the prefix here. Now let us see some of the examples. Now as you can see here, we have 200 and then we have three zeros and then this is meter per second. So these three zeros can be replaced by 10 to the power of 3, and as I told you last time that 10 to the power of 3 is basically equals to kilo, which is small letter k. Now you can see here these three zeros, these last three digits zeros can be replaced with 10 to the power of 3, and this 10 to the power of 3 can be replaced with kilowatt, which represents the kilo. Now we can change this kilo into the megawatt. How? If I change the decimal place, because we know that our decimal always lies at the end of the last zero. Now if I shift these decimal points towards the left up to 3 digits, like if I go from here, then here, then here, then here, so I have shifted 3 digits, so it will add 3 more zeros here. So 3 zeros from kilo and 3 more zeros when these decimals are shifted there, so that would be 10 to the power of 6. So it would be 4.8 into 10 raised to power 6 watt, and 10 raised to power 6 is equals to mega. Similarly, you can see here example which is 3300 and then we have 6 zeros again. So first of all, let us consider last 6 zeros which I have changed into 10 raised to power of 6 because 10 raised to power 6 is mega and mega contains 6 zeros. So just by the the other numbers come as it is, only these 6 zeros are represented as 10 raised to power of 6. So 10 raised to power of 6 means megahertz. Now we can convert this megahertz into gigahertz in the same way. As I told you, like the decimal point is always at the end of the last zero. So if I move this decimal point towards the left side, such as 1, 2 and 3, so it would be 10 raised to power 3 added here and this mega comes as it is. So this 10 raised to power 3 and this will become 10 raised to power 3.3 into gigahertz, which is 10 raised to power 9 because 10 raised to power 3 this and 10 raised to power 6. So these two powers will be added, like 10 raised to power 3 plus 10 raised to power 6. That would be 10 raised to power 9 hertz, which is represented as gigahertz. Now let us look at the fourth example. You can see the fourth example here. We have a digit which in decimal point such as 0.00002. So if I move this zero, this decimal point, to just before the 2, so I am shifting from 1, 2, 3 and then, or let's say if I move to 0, like if I move the 0 just before the 2 digits, like this place here, so it would be 1, 2 and 3. So 0.02 multiplied by 10 raised to power minus 3. Why minus? Because now I am moving my decimal point towards the right direction. That's why I have a negative power here. So 0.02 times 10 raised to power minus 3 gram equals to 20. So if I again move these decimal points further towards the 3 decimal points, 3 digits, so it would be 20 into 10 raised to power minus 6 grams, which would be 20 micrograms. Now let us look at the last example. So if I move this 0, such as like from 1, 2, 3, 4, 5, 6, so it would be 0.0081 into 10 raised to power minus 6 meter. Now if I move this further until like the last decimal point after the 8, so it would be 8.1 times 10 raised to power of minus 9 meter. So it would be 8.1 nanometers. So here you can see a diagram which are multiples and some multiples of length, such as kilometers, which is 10 raised to power 3 meter, centimeter, which is 10 raised to power minus 2 meters or 0.01. Then we have millimeter, which is 0.001 or 10 raised to power minus 3 meter. Then we have micrometer, which is 10 raised to power minus 6 meters. And then we have nanometer, which is 10 raised to power minus 9 meter. The important thing to understand is that when you move the decimal point towards the right direction, then you make the power negative. And if you move the decimal point towards the left direction, then you have a positive power.